你不能 mute。invite，然后看一下你的meeting password。join meeting。我能先把你给拔一下啊。
好好。
我给他说。是。
他人还没来，
他来了。
刚才就走了。
然后他不是说今天还有一个会议是有一个人缺席的嘛，然后需要跟他说进行会。
哦。
他 online 呀。
啊。
OK。
我当时带电脑过来跟我等过，就是我到时候陈老师他在前面该怎么讲怎么讲，拿我的电脑先给他录。然后等到那个人 online 的时候，陈老师那个投屏的电脑在
那你一直待这儿吧。
对，是的，但是里面还有一大堆测试 file，我也得去弄一下。
那你去吧。
我去跑会上，我点一点
就是今天现场要颁奖。
对，今天现场颁奖。
是在哪儿颁奖？是在这儿还是在别的？
Hi. Are you guys the volunteers?
Yeah.
Yeah. I'm Alice. I'm the AV tech here to help you guys with any of the ICC tech.
Okay, thank you.
So are you guys?
Yeah, like they have the online speaker. So I think do we need to change the operation board a little bit?
So is this the laptop you'll be using for the slides?
Yeah, this one.
Yep.
You've got that plugged in. Sorry, wait a minute. 你知道你这个邮箱吗？它需要 join 这个 Zoom 需要邮箱。
对，就是对啊。
这是你老师的邮箱。
用我的。
用他的吧，这是他的邮箱是不是？
对。
好，那我看一下，我觉得。
我们把它 join 进去。
对，因为他需要他的邮箱，所以我就得。
那个啥，你在他那个 UTS 那个邮箱是在你搜那个。
哦，他没有联网吗？连着了呀。
对，连着的。
对他，你知道他的邮箱吗？你输不输？
你输吧。
不，不，没看。给我。
是 UTS 用。
他可能用 UTS 的那个字母灯。
这样子。
也没关系。
没关系，只要我们能 invite 就行了。
maybe 就是用他那个的，我觉得可能是最简单的。可以了，好。他不是 host。可是他不是我们 host，他要 join。
对对对。
那。
所以就是要这个。
好，那你们。
所以
就是
他的邮箱。
对，我们要输，不是，就是我们现在在这里输这个。
要老师邮箱是吧？
对，因为我刚输到最后一步，他是需要他的邮箱。为什么？
没，这键盘没用。
对 ，sorry，我直接。
直接把键盘放起来了。
OK。
哇，填平台的东西好难吃啊。
还好啦，还好啦，有吃就行了，你要求好高呀。
对，他的 email 就是。
我来。
这好像是 verification。
哎，老师。东西在那儿，那个讲堂在那儿，然后电脑我也带过来了。现在把这个拉到你们可以去。
哦，
对对对，
好，
试一下，我们先试一下。
join meeting。OK，
Recording in progress.
OK OK，那我就把这个拿后面去。
等一下，我把它这个声音关掉。或是你 mute。OK。
我拿着，我拿着。
或者你把它 mute 掉。你可以把它 mute。join。
Recording in progress.
四个没关。OK，是不是？
是，我去后面把它音频设备连上，然后你试试看，在老师电脑上能不能那个。
那我们还有一个远程的人，你的那个 Zoom 的 link 给我，我叫他远程参加。好，你就把 Zoom link 发到。什么意思？就是，我给你这个，你不是要给我邮箱，你把 Zoom link 发到他邮箱。
可以，可以，可以。
Yes, it's currently having problems. I've got some people that are going to come down and get it turned on.
OK。
The screen is not work, so doesn't work now, but they find some people to fix it.
安点章3.14。
There was a problem with this room yesterday as well in terms of the HDMI was having issues.
Oh, okay, cool. So it's probably the same issue. Yeah, they have the online speaker. So.
Yeah. There's an online speaker. I thought oh no, this isn't a research track. Okay.
Hello，Hello，
现在就是并不是我这个。对，他现在还是
Want this laptop
Hello，
working?
Yeah，Hi，你能听到吗？有声音吗？
That'll be why it's not working.
You're a legend.
Okay. Who's this?
I have no idea.
Yeah, yeah, cool. Thank you so much. Yeah.
Check your camera and your sound and usual things.
Okay.
Thank you. That's everything here.
Just want to ask a question. You're not supposed to drive essentially on the final stage, right? Yeah.
It's the same. Oh. So Zoom is Zoom. So input, microphone is going to be the Go box. Output is going to be the But yeah, this is a good cheat sheet. Oh, thanks. Hello. I heard it's your birthday. Not my birthday. I just want to know how do you figure out the Zoom link, like you joined a specific Zoom, right? Yeah. So how did you figure out when to join? Apparently they say it's in the app, but I because I use the Huawei. I'm the Huawei member, so I can figure it out. Like I am C2.5. Oh, can I just download the Slack and I mix them? I think it will work. Yeah. What's the name? Yes. I'll do that. 3.5 this one. I actually downloaded. Listen, thank you.
对，有的人他是自己那儿取 poster 的时候，就直接给他，让他自己找。啊，对，没了。
How's the setup in here? It's good now.
Hello，测试。
Can you tell me your number and I will send you. I'm 2.6. I will listen. Online. You cannot see. You only can watch it from the guy with email. They send the email. Can you just send? On your number in Slack. Yeah, in Slack. Okay, thank you. You tell me immediately. Control.
Test.
没声音啊。我觉得可能也不需要吧，就是 online 那个人不知道听。啊，那我们就开始吧。OK.
So,
Good morning, everyone. Welcome to Women in the Web program at this year's web conference. This year, we are excited to introduce a new initiative, an award to recognize our outstanding early to mid-career female researchers. And we have received quite a number of highly competitive applications. And as organizers, we are very delighted to see so much incredible achievements made by our female researchers in the field. And today we are going to announce the winners. And before that, we invited a very successfully established female researcher, Professor Flora Salim from UNSW, to give us a talk to hopefully inspire our fellow female researchers to pursue high quality research and deliver high research impacts. So Professor Flora Salim is with the School of Computer Science and Engineering in UNSW. She's the inaugural Cisco Chair of Digital Transport and AI, and also the Deputy Director of UNSW AI Institute. Her research is on machine learning for time series and multimodal sensor data and on trustworthy AI. She has received several prestigious fellowships, including Humboldt Bayer Fellowship, Humboldt Fellowship, and the Victoria Fellowship, etc. She has attracted more than 20 million in research and industry fundings in the past 10 years as lead associate for more than half of these grants, including research funded by ARC, Microsoft Research US, Northrop Grumman Corporation US, Qatar National Priorities Research Program, Cisco, IBM Research, several city councils, and many other industry and government partners and funders. She is the chief investigator on the ARC Center of Excellence for Automated Decision Making and Society, co-leading the machines programs and the mobilities focus area. She was the recipient of the Women in AI Awards 2022 Australia and New Zealand in the defense and intelligence category. So with no further ado, let's welcome Professor to give us the speech.
Thank you. Thank you, Ling, for the invitation. And first of all, I'd like to acknowledge the traditional owners of the land and the Badigal people of the Eora Nation of the land where we're actually right now attending the conference. Okay, so I'm from UNSW, University of New South Wales. How many of you here is your first time in Sydney? Great. Welcome to Sydney. And how many of you actually have visited us before at UNSW? Great, the locals. So UNSW is actually not that far from here. We actually close to the beach. So if you have a chance to go to Coogee Beach, we actually just 5 minutes drive from Coogee Beach. So in fact, that's why actually this is my lovely group. Let me see if I can go next. Yep. My lovely group, we often, after our group meeting, like 2 weeks ago, when the weather is good, we go to the beach and then we have dinner together. That's one of the way where we actually try to have balance. We work hard, work smart, but also we want to build a community. You know, our research group, we are like a family. We support each other. And this is actually what makes us different as female professors. You know, our male counterparts, they only care about work, right? We as female, we actually have a nurturing value in us. That's just something within us. And I think we bring something different to our faculty, to our department, to your group, okay? And let me tell you a bit of background where I come from. So when I actually finished my degree at Monash, I started as a senior software engineer in Media Proxy. This is a company that still exists now. Actually, the digitalization of broadcasting industry of, I will say 70-80% of them actually was done by the software I did in 2003. So that gives away how old I am. That was before I did my PhD, and then I got scholarship from Monash. I went back to Monash, and then I climb up the. I went to RMIT. This is RMIT logo. Climb up the academic ladder in RMIT, and we are now here. I'm with UNSW and leading two centers, research centers, and also deputy director for AI Institute. But let me tell you what happened in between. So this was 2009 when I finished my PhD. And I joined UNSW 2022. Got two babies. Okay. So this is a period where I did a postdoc, and you see there's two different logos. You might wonder why you put two different logos. Actually, these represent two different schools. I actually joined as a postdoc of someone who got ARC Federation Fellow in Architecture and Design. So I was a postdoc of someone who's an architect, but he's got a Federation Fellow, which is like the most prestigious fellowship. This time is called Laureate Fellowship. And he wants to revolutionize the way buildings being designed. And he's actually chief architect of Sagrada Familia, the tower the church tower in Barcelona that's never finished. That's actually was completed in RMIT. We did the multi-objective optimization in the lab, and part of that was, what I did during my postdoc. But so it was quite a big deviation because my PhD was on sensor data mining. And I finished my PhD 2008, 2009, global financial crisis, not many academic jobs. There were some industry jobs, but and then I found this professor's position quite interesting, but I started from ground up again. It's like doing PhD again during my 3-year postdoc with him. But then he also supported me with my academic career. He said, what is that passion that you want to do? And that is important. I don't know how many of you are still postdoc or just finishing PhD soon? No? You all have got tenure? Yeah. Okay, I don't know which group are you in. But I think it's important to get a group to get an advisor, even postdoc advisor that supports you. And he supported me to apply for my own grant, build my own connection. And he even introduced me to a lot of important people in the area of smart cities, because I work a lot of sensor data mining back then, and my area is very, very small, which is the area of road safety and transport. But because he's an architect and also urban designer, he knows so many people in the government. And so I actually started my own linkage grant, ARC grant, right? And that's like as equivalent as prestigious like NSF in the US, for example. And I became a postdoc fellow. So that time, now we call it DECRA, but back then it was called APD. So I've gotten this fellowship with the grant I apply myself. So, and in between, I've got child 1, child 2. So this is when I climbed my academic career from being a postdoc to lecturer to associate professor in 2018. And during that time, I managed to win 3 different fellowships. I grouped them all to take my big break, which is sabbatical. So within 1 year of sabbatical, I became an affiliate associate professor, visiting associate professor in Cambridge and Kassel. And then I went back to RMIT before I joined UNSW. So that's a bit of my journey. And I went back not just to, so my home, because I work on sensor data mining, my home community is actually UBCOM and also data mining community. But since I work with these professor in spatial architecture, I branch out another home. I've added another home, which is 6 spatial. And so your academic community might grow during your academic career. And since 2018 or 2019, we published more in machine learning and starting having papers in Europe, in ICLR. And that's, I mean, I would not call them home because it's too big. But web conference is also one of my home, the last 5 years. Apart from that, I've been serving also in national committee, for example, Australian Research Council, which Ling is also serving, Australian Academy of Sciences. I'm part of the National Committee for Information Science. And also I'm part of the International Committee for international energy agencies for building and communities. So if you want to know what's my research right now, basically it's foundational AI for open world reasoning. Some of these projects are basically, some of the pictures are representative of my project. I do a lot of work with smart city and government, being able to tap into not just open data, but data that are, proprietary. Could be large scale mobility data, could be transport data, could be data coming from smart buses in Sydney, could be data coming from electric grid. We work with electricity providers and grid distribution companies as well here. We also have project with defense prime industries, such as the project with Northrop Grumman. I got access to large scale GPS data from US airports. And what you see here is LAX airport. We built situational awareness map completely ground up using representation learning, not just to build the map, to construct them, but also we can classify activities, classify whether it's actually large plane or private vehicle, or is it actually catering car rather than baggage handling car. So we can then, and then if there's an anomaly in the wait time and all that. So that's what we did for Northrop Grumman. This is one of our current project right now, which I'll talk about really briefly as well. We are tracking avian flu in the US. So you might think, why your research is so broad? It has so many different areas. Fundamentally, what we do is foundation models for multimodal time series and spatial temporal data. So since my PhD until now, I've been very much focused on looking at patterns in multimodal sensors. So these sensors might be in your phones. Even when I actually started my PhD, I started collecting data from my own it was not called smartphones, it was an old Nokia phone, accelerometer and gyroscopes. And then we built a lot of toolkit to collect this data. Smartwatches, we work with now even with companies like Nokia, Bell Labs in UK. We're working with, some of you will be wearing AirPods, right? The new version of AirPods actually have a lot of sensors as well in there. So it can be used to detect human activity. You can detect signs of anomaly of health. Also, it can be used for human productivity monitoring. But if you collect these at scale from buildings, from roads, these are spatial temporal data. So fundamentally, these are the kind of data we work with, and we want to build models that can be generalizable across any kind of data. So not just one specific type of trajectory data, not just check-in, not just GPS, but basically multimodal. And if you think about it, it's actually very challenging. And there's a lot of challenges with real-world time series and spatial temporal data. First of all, a lot of the publicly available time series data out there, I would say they are toy data sets, because they're very much collected in environment that is either they made synthetic Gaussian noise and they just make some corruption for anomaly, for example, or they are just univariate signals. But real-world time series spatial temporal data, they are very heterogeneous. Even the same sensor, air temperature sensor, even accelerometer, if it's placed in your watch, or if it's placed in in the earbuds or in a mobile phone, they're all different. And because and you need to find a specific way to process them. And the problem is, it's not much data out there, labeled data, and this data always irregular, and different sensors have different characteristics. So how do we actually deal with dynamic time series spatial temporal data? So if there is something quite special about our group, we focus more on dynamicity. We are not content with easy toy data. We work with real world data, and some of these methods that we have proposed are very much, a lot of them are the first for time series and spatial temporal data, self-supervised learning methods, augmentation and masking strategies for spatial temporal data, novel neural ODE based methods, and so on. Let me just show you an example why this is hard. Imagine on the left, you know, I can ask you right now, if you are all my Mechanical Turk workers, what is this image? Can you label that? Bear, it's a specific type of bear, which is a polar bear, right? And that's an albino kangaroo. We all can call it out. Now, can you tell me what is the label here before timestamp 50-50 and between 50-50 to 50-75? What's happening here? If you are my Mechanical Turk workers, any idea? No, very difficult. But these are the kind of data that are a lot more than images and text in the web. These are data coming from machines, from your phones, from these buildings, from everywhere. And I would say this is the next frontier of AI and machine learning, understanding the physical world from time series data. I can tell you, because I see this data all the time since my PhD. That's basically, if this is actually an accelerometer data, then that's coming from watch, XYZ, and that's a heart sensor accelerometer placed here, like a pacemaker. Then you can tell that, for example, here, somebody heart rate going up, this guy might be jumping, but you can see from the accelerometer Z, the axis going up and down. So that's a jumping activity, where that's actually walking. You need a domain expert. Now that's a problem. And how do you do it without domain expert? You will do some transformation, signal processing, wavelet transformation, or you can do frequency-based transformation, and you'll see if there's an anomaly. Let's say, for example, just from a univariate ECG, you need a doctor to tell you if your heartbeat has an anomaly. But we can use feature engineering, of course, to do that, right? To detect anomaly. But how to do it with a domain expert? We are the first, one of the first that actually look at self-supervised learning for multimodal data. This work have been published in UBCOM in IMWOD since 2018. Let me just show you one of the most recent work that's adopted by industry from our group. This was published last year in Wisdom. Imagine you have users and you want to be able to predict their activity and model their behavior over time, right? But users in the system, and this could be Apple, right? Any big company, Google or Apple, some users might be using their phone, some people will be using maybe the Google Watch, but some just using Apple Watch. And you might be having AirPods as well from Apple, which already have sensors, as I told you before, and soon glasses, AR glasses, okay? Meta already have Ray-Ban glasses, but Google's just released one last week. I don't know if you've seen it. And you want to be able to predict activity, not just physical activity. You want to be able to see information, interaction, behavior while they're searching on the web. You want to see what attention on the web, for example. You want to be able to look at this, what we call cyber physical social behavior. But this data, there'll be no perfect user who has everything. How do you do pre-training if you require users to always have all the sensors all the time? This is completely nonsense. It's not going to happen, because you and I know sometimes we leave our phone at home, right? So this is where we come up with a model, and not so. This is actually the third iteration of our work. In this one, we specifically introduce how do we do modality specific pre-processing without label. So how do you do masking on a specific modality, and then how do you do local embedding within each of the, and what we call local is basically within the same time, within the same epoch. That's local embedding across modality, and then we also learn the correlation among sensors. So which sensors are highly correlated to each other, and then we actually then also learn the global embedding for the to be able to be modeled for the downstream task. Okay, and what this model does then, it's able to cope with missing sensors, either in pre-training, either in fine-tuning, or in inference time. So if you want to take a look, check the paper. The code is available. The solution is also patented and is now being used by Nokia Bell Labs. A couple of other work we're working right now. We believe that language models can help. providing semantic. And if you look at a lot of LLM work for time series these days, a lot of these LLM work for time series are very much focusing on forecasting. Forecasting is still a hard problem, but classification is a harder problem. Because with forecasting, you have the ground truth, which is you can just, hide some of the recent data and they can become validation and testing. But for classification, often you still don't have the ground truth labels of the activities. And these activities can come in actually different resolution. So I think we're one of the first that come up with LLM that can work for human activity recognition. It can do trend analysis, summarization, and you put in the sensor data. You can actually ask these to be to classify the activity. Some other works that we're working on, we also very care about, again, dynamic, right? The issue of dynamic. The thing is, often the model, because we work with real world partners, they care about robustness. So you might have a pre-trained model exposed to specific tasks, but over time, the model has to answer queries on new tasks that has not been trained before. So this is where we come up with the first benchmark on continual learning for multimodal time series and video. So Wilco Bench is a benchmark paper in NeurIPS last year. We have released this as a video text benchmark and data set that has QA, moment query tasks, all the video understanding query tasks. And if you want to see, all the other benchmark are very much only for continual learning benchmark, specifically continual learning benchmark are only on image or text or just on video, but they are actually pretty small. So all the other benchmark have very small number of tasks. It only tested on limited number of tasks. We have a comprehensive evaluation, more than 22 tasks, and also the highest number of frames per sample. And what makes it tricky as well, the sample that we have, the frame are just 10 minutes videos. And we also put a challenge on memory efficiency. So this sample was curated from Ego4D for moment query, natural language query, and visual query, for example. And again, different kind of questions. And I don't have the slides on results, but take a look at the paper. We introduce the short-term clip-like embedding mechanism to align the embedding of video as well as text. And we also have the long-term memory buffer that can have selective forgetting. The selective forgetting mechanism is quite important because you don't want to have catastrophic forgetting when the model is learning new tasks and forgets what it's been able to do just recently. So the selective forgetting mechanism is something that we introduce as well in Wilco. So as I said, we very much care about all these problems. I mentioned as well here, we care about handling unseen tasks, OOD. We care about handling missing data, and also we care about irregularity. So an example of irregularity here is SecLink. So in this project, what happened is a lot of time with time series, some sensors are sampled maybe 100 Hertz. Some sensors only come every 15 minutes, and some are not even periodic, it's event-based. So how do you actually align them? If let's say you want to use an encoder-decoder architecture, transformer-based, you need to make sure that everything is aligned, and you need to make sure you can tokenize them, right? Each of them is basically discrete representation. But we believe between observation, you cannot just do a simple imputation. You cannot just do simple fill the blank, because with time series, it is actually non-stationary, and there's a trajectory between observation. And the longer the missing observation is, the harder to know the trajectory. And this is what we do here. And in this paper, what we enable is you can just plug in your sensor data. Imputation will be done on the latent space using latent ODE. So we came up with a way to sample the hidden trajectory using ODE autoencoder, which we propose. And in here, by being able to corrupt and reconstruct the data iteratively, we come up with a very robust latent representation, ODE latent representation, which then, when you actually, this is per sensor or per channel. And then we have the pyramidal attention that can look at, that can sort the important correlations among sensors for whatever downstream task that you have. So that's basically what we do in this paper. Let's take a look at our most recent paper on this topic on irregularity and also online learning is sometimes when distribution change, the one way to deal with this, you need to have a memory buffer, right? And one of the way to do it, continuous learning, is to do experience replay, for example. But what we do here, this is the first buffer-free framework that can adapt latent representation. And what we have is we store the latent representation, not the data representation, but the latent representation. This is a VAE ODE, so ODE VAE, and we update this dynamically. The details in the paper, take a look. What is also very interesting, we not only outperform industry standard like FSNet coming out of Salesforce, just published 2 years ago, it's also very, very fast. They're up to 30, 40 times faster because a lot of these existing online learning mechanisms require buffer. This is the thing that we cut out. So you can actually run this really quickly. And you know, all of these things, all of this innovation come out of academia from my group. Why? Because we don't have enough GPU. That's one of the reasons we have to innovate. I'll skip some of these because these are some of the work that we're working on, which is what we've been working on in our group, traffic forecasting on multiple roads and hundreds and thousands of nodes. Traffic forecasting, even if you haven't seen part of the road or completely new road network. And that's using self-supervised learning. We've done this for traffic, energy, weather. We've done it for unseen events. For example, during terrorist attack in Boston Marathon bombing, we can predict what is the demand across different transport mode. We collaborate with Japanese University of Tokyo, what happened during earthquake in Japan, for example, and also COVID lockdown. We also do forecasting during extreme events like bushfire, storm, when the poles fall down. Can we predict what is the energy demand looks like, energy prices looks like? These are actually working with again companies. Unfortunately, with this one, for example, we can't release the data sets, but it was really fun to work with this real world companies data. One data set that we released though is this one. This is the project. We just finished running a competition in the web conference. The workshop was was yesterday. In this project, in collaboration with a lot of companies and New South Wales government, we've collected sensor data from all these appliances in buildings, into 3 buildings in New South Wales. It has more than 15,000 time series across more than 300 classes. And we also have the knowledge graph. So as I said before, the challenge here is not to just classify this is an air temperature sensor, for example, but this is part of this air handling unit and it has a set point. And this is the sensor that we need to pay attention rather than the sensor that is somewhere in the chiller beam, for example. So the challenge here is not to classify only the one label, but hierarchical label that this actually belongs to this HVAC zone and things like that. So we can comply with the BRIC schema. So take a look. We also have run international AI crowd challenge on this with prizes up to $20,000. It was all disseminated yesterday at the brick by brick competition at the web conference yesterday. We actually the first who built forecasting mechanism with natural language processing. So this is a paper in Wisdom. We also have a global patent on this on this forecasting with natural language. ChatGPT was released November 2022. We did this in June or July. If you remember, wisdom submission is always July, August. We got this paper published in February 2022. So we are actually 1.5 years ahead. We borrowed an idea from GPT-1 and GPT-2, and we thought we can actually potentially look at transforming numbers in and numbers out for forecasting. And then rather than actually having to embed every context data, we can actually just turn them into a prompt, and we can do zero-shot forecasting. So that's what we did. There are a couple papers following that. We also have a data set and benchmark on this forecasting with natural language. If you look up PromptCast, again, this is a work from 2021. It's only published in 2023 and TKD, but take a look. If you know how to fine tune your model, because right now, if you use ChatGPT to do forecasting, it will fail terribly. You can see, for example, electricity load forecasting with ChatGPT. This is only GPT 5.5 because this was submitted in 2022. The error is huge, and also the API cost is huge. But what we did, we fine-tuned BART, Big Bird, Pegasus, small language models, not large language models. Okay, and this is the API cost if we host them on AWS cloud. So you can see the cost is small, and also the RMSE is very small. So we have actually outperformed all the state of the art, including FedFormer, Informer, and all those things since 2022. Okay, again, since before ChatGPT was released. We also are, oh, sorry, where are we? We also were the first to do LLM for POI recommendation. This is a paper in CKIR last year. Again, looking at trajectory prompting, and we did a key query similarity comparison, and then supervised fine tuning. These are the 3 recipes to make LLM work for your data without having to train from scratch. These days, what are we working on? We are working on agentic simulation for cities, social and physical simulation. We have a demo paper. If you're interested, you can check. Actually, there's a demo session happening now. So straight after this, I'll go and see my student there. And also we have a poster about this. We can generate synthetic data that are very close to real data. We have ground truth data. And to generate data based on people's behavior, their likelihood, how they travel around the city. We can generate, it's based on not just big 5 personality trait, but it's also based on historical routine pattern. It's also based on their preferences and things like that. As I said, we've been working on simulation these days. We're also working on LLM-based and heterogeneous information network-based model to be able to predict outbreak before it spread, become a pandemic. And the focus of this project is avian flu tracking. This is a project collaboration with the US, with a lot of other universities here, as you saw. So what we did here as well, what is quite new and interesting is a lot of the pandemic reporting data is very biased. Not some people, so it's always underreporting. So how do we correct the bias? This is how we do it in simulation. You can actually inject bias in simulation and see if we can then confirm there is this ground truth simulated bias can be detected through the model. So we combine both data-driven model with simulation. I'm recruiting for a new center. So this is a center I'm co-leading right now on whole life design of carbon neutral infrastructure. Still recruiting for PhD. In this project, the biggest challenge again with a lot of this data, we don't have training data about what is the carbon life cycle for this building, for the bridges, for the road, for the next 10, 30 years until the end of life. So we will do, we'll leverage, of course, generative AI for this, as well as a lot of past technical reports and also scientific papers, hopefully to come up with new new material repository for the community. So again, all of these are done by a lot of my great students and postdocs. So if you're interested to collaborate, feel free to contact me on floor. Thank you.
Any questions about the research or how to make work-life balance or how to handle this research measures?
Hello, Prof. Flora. Thank you very much for your very interesting sharing. So I do have two questions. Yeah, so the first one is that because you are using the sensing data, right? And they are very private data. I know you are collaborating maybe with the government and the industry. So how can you handle the ethical issues when you're using the data? Yeah. So this is my first question.
That's very good. First thing, we never work with personally identifiable information data. So even when we work with industry partners, the first thing we want them to check is make sure there's no, it's all anonymous and we cannot reverse engineer who that person is. So there was one project where we work with public Wi-Fi data from Westfield Mall. So we collaborate with Westfield Mall in Pitt Street. And that public Wi-Fi data has email addresses. Okay, so what we did, we generate a script for them to basically just hash everything, double hashing, and then anyone that's quite unique in the data. So we use K anonymity to remove them. So that's one of the principles that you need to have in your group to make sure that you, as a researcher, right? We're not companies. As a researcher, we are responsible with the data that are given to us, even when you work with industry partners and governments. And second, there's also opportunity to work with publicly available data sets that are similar to the proprietary data. So sometimes it's hard to publish because you cannot share the data set. So what we've done in the past, that's why we always try to collect our own data, which we can publish, or we can also then use publicly available data sets that are quite similar to the data that you work with in a company, and you publish the paper based on that data set, and then you deliver the code or the model that work with the company with using the company data set. I hope that makes sense.
Okay, thank you very much. So my second question is not related to your talk today, but it's how to manage the time, as a faculty member. So we are very busy, and maybe we need to secure funding, supervise students, and conduct the research, as well as some services. And I know you have two babies as well, right? So you need some time to accompany your kids. So how can you handle everything very well? Yeah, thank you.
Thank you. That's a great question. To be honest, I think this should be a team effort. And I think with the family, that's something you need to manage with your partner. From upfront, the partner needs to agree that this is a team effort. The academic journey is hard, right? So if you're in it, you're selling your life to it, really. And second, you have to think about carrying other people with you, because you're also training them together. For example, applying for grant. I involve some of my postdocs and also senior PhD students who need, if they want to do academia, of course, not industry, they won't care about applying grant, right? But those who want to stay in academia, we're actually responsible to train them on how to write grants. So we can actually involve them, not just if they know how to write paper really well, do they know how to write grants? You can involve them from beginning. They can help you to write, but you can then use it, change it, and you say, this is how I'm going to do it. Okay. So it benefits you, it benefits them. So this actually shared the load, and they learn. To be honest, when I was a PhD student, I complained so much that my supervisor made me to do so much work. I wrote grant for her. I did teaching for her. She went on maternity leave 1 year. I took her courses, but because of that, I got grants. I got ARC grants not long after I finished my PhD, because I got the experience. I got lecturer position directly because I have long list of courses I've taught. I hated my supervisor so much back then, but now I love her so much. I said, thank you. That was a hard training period, but it really helped me, and it really helped her too. So that's something you have to think, that your team is really a team. But also, as I said before, right, UNSW, we benefit from not being far from the beach. So I take my students to the beach. We go for dinner together. So we're like a team. We're really a family, you know.
Thank you. Thank you very much for sharing your experience. Thank you.
Thank you. Thank you so much.
Can you stay to present them to them?
Okay.
So we're now going to announce the winner of the Rising Stars of Women in the Web Award. And the winner goes to Dr. Zhu Sun from Singapore University of Technology and Design. Congratulations.
Thank you. Thank you.
Yeah.
Oh, you should be here as well. Okay, I should, as the chair, you should be here.
And we also have two runners, but only one of them is able to come today, and the other one, because of visa issues, she has to attend online. So we have the runner for Dr. Qi Cao. Congratulations. Congratulations.
Thank you.
Okay, thank you. See you. So now we are going to invite the recipients to share us their research stories and works. Okay. So first, welcome Dr. Zhu. Can you share your screen?
You already shared screen.
Maybe
Oh, yeah, I think so.
a brief introduction about Dr. Zhu Sun. So she earned her PhD in computer science and engineering from Nanyang Technological University, Singapore. After completing her doctorate, she worked as a data scientist at Shopee Singapore, the largest e-commerce company in Southeast Asia. Then a lecturer at Macquarie University, Australia, and then a senior research scientist at A-Star Singapore. Dr. Sun's primary research focus is on trustworthy recommender systems. She has made significant contributions to the research fields and published over 70 top-tier papers in venues like NIPS, AAAI, SIGA-IR, KDD, the Web Conference, PAMI, TKD, and TOIS. With over 2,300 citations on Google Scholar, and receiving a series of awards and recognitions, including the Best Paper nomination at SIGA-IR 2024, Best Journal Paper Award at Recommender Systems 2023. So yeah.
Yeah, thank you. Yeah, good morning, everyone. Yeah, thank you very much for the introduction from Dr. Chen. Yeah, and also I appreciate the chairs and the organizers to organize such kind of wonderful events, and so that we can get together. Yeah, and also I appreciate the community's recognition of my research. Yeah, thank you very much. Yeah, so my name is Sun Zhu. So currently I'm an assistant professor at Singapore University of Technology and Design. Today it's really my honor to give this talk. So can I have the microphone? Can I have the microphone? I think this one. Okay. Oh yeah, I'll try to use this one. Yeah, I think this one's much okay. Thank you. Yeah, so it's really my honor to give this talk, and the topic of my talk is leveraging LLMs for recommender systems. Oops. It's not very stable. Okay, yeah. Okay, sure. So as you may know, the techniques for recommendation is fast changing, and from the heuristic methods at the early stage to the matrix factorization methods and deep learning models. And currently we have been extensively using the large language models for recommendation. So the LLMs has reconceptualized the recommendation task as a natural language problem. Therefore, a critical research question has raised, that is how to leverage LLMs for effective recommender systems. So in today's talk, I will introduce several of our works that utilizing the self-reflection, reasoning, and the generative capabilities of LLMs for recommendation. We have done several works about leveraging the self-reflection capabilities of LLMs. So one paper was published in CKR 2022. So in this paper, we use LLMs for intent-driven recommendation, and our focus is to automatically optimize the prompt for LLMs to make a more accurate recommendation. And the second work was also published in CKR 2024. So we are using the LLMs for bundle generation. So given the bundle, we use the self-reflection capabilities of LLMs to infer the user's intent as well as the corresponding bundles. So these bundles can be used for the downstream task, like the bundle recommendation tasks. And one of our recent work was published in AAA 2025. So in this work, we are using a lightweight retrieval agent to retrieve the relevant hints to improve the in-context learning capabilities of our LLMs. So in today's talk, I will mainly focus on our AAA papers. So as you may know, there are several different paradigms to utilize LLMs for recommendation. At the early stage, I mean, not very early, just in 2023 or 2022. So there are many works, they focus on in-context learning and focus on the prompt optimization methods without training the LLMs with the user item interaction data. Well, this crafted prompt, they requires domain knowledge and human labor, and maybe they are not very well aligned with the LLM's understanding towards the recommendation task. And then, so there are several works, many works, they propose to fine-tuning LLMs with the domain-specific knowledge, that is the user item interaction data. Well, these methods, they suffers from the high computational cost, and they rely on the open source backbones. So these limitations has restricted the practical applications of LLMs for recommendation. So to address these issues, we propose to effectively and efficiently leverage the specialized knowledge to improve the performance. So there are actually two challenges. The first one is how to effectively extract the specialized knowledge embedded in the user atom interaction data. And then the second is how to efficiently utilize those specialized knowledge. To this end, we propose our models that is the reflective reinforcement learning LRMs for session-based recommendation. So first of all, we create a hint knowledge base. So the hint will be utilized to summarize the mistakes that LRM has, the mistakes the LRM has made during their inference, and then based on this hint knowledge base, we train a lightweight retrieval agent, which will be utilized to efficiently retrieve the most relevant hints to prevent the potential mistakes that will be made in the future when LLMs do the inference. Okay, and so this is the overall framework of our proposed methods. So the yellow part is the first module, that is the reflective exploration module. So as I introduced, so we mainly use the self-reflection abilities of LLMs, and we identify and summarize the inference errors. And then based on these errors, we generate hints as the specialized knowledge. Because the hints is generated by the large language model itself, so it will be more easily for the LLMs to understand and digest. And to ensure the quality of the hints, we further have a module that is the automated filtering strategy to ensure the effectiveness and diversity of the hints. Hello. Okay, maybe there is something wrong with the microphone. Okay, I'll use this one. And the second module is the reinforcement utilization module. So in this module, we employ the deep reinforcement learning to train. Thank you very much. To train a lightweight agent without the costly fine tuning, and the agent aims to learn to select relevant hints to get the LLMs in mitigating potential errors in the inference. And lastly, given the retrieved hints, we can enhance the prompt, and then we can instruct LLMs for more accurate inference. Okay, so this is the first module, that is the reflective exploration module. So in this module, there are key two steps. So one is the self-reflection generation, and the second one is the automated filtering. So in the first step, there are 4 sub-steps. So first of all, we use a basic prompt to instruct LLMs to do the recommendations for a given session. And then for some of the cases, LLMs may generate wrong recommendations. So given these cases, we will further ask LLMs to identify to analyze the causes behind the errors. And at this stage, we don't give the ground truth for the LLMs. So this will allow the LLMs to explore the diverse causes behind the errors. And then in the next step, we will give the ground truth to the LLMs to identify the accurate cause for such error. And finally, we will ask LLMs to summarize the causes as hints, which could be easily digested by LLMs. In the second step for the automatic filtering, so to ensure the quality, because we will have a lot of hints after the first stage. So to ensure the quality of the hints, we do have the automated filtering strategies to first of all, we enhance the effectiveness of the hints. So only the hints so we will only if there is improvements by using the hint enhance the prompt compared with the basic prompt, we will add these hints into the knowledge base. And then we find that there are a lot of redundant hints. So to ensure to reduce the redundancy, and we compare the semantic similarity between among different hints, and then only keep the diverse different keep the hints with different semantics. The second module is the reinforced utilization modules. So because we do not have explicit labels to indicate whether the hints is effective or not, so this inspires us to use the reinforcement learning method, deep reinforcement learning methods. So we model this process as a Markov chain process, and the state will be the session, item titles, and the attributes. And this text information will be fed into a pre-trained BERT model, and then the action space will be the knowledge base with the hints. And we use the comparative reward by comparing the performance using the hint enhanced prompt with the basic prompt. And then we use the PPO algorithms to train the models, and we train the policy network with an MLP structure, which map the state into the action space. And finally, we retrieve the appropriate hints and then enhance the prompt for more accurate recommendation. And regarding to the experimental, we consider two public data sets. One is the MovieLens data set, and the other is the Amazon Games data set. And we compare with several numbers of SOTAs, including the traditional deep learning methods and as well as the large language model-based methods. And we split the data into training, validation, and test, and explore the commonly used evaluation metrics and more detailed, implementation details. You can refer to our papers. And these are the results. So the first part is the overall comparison. So in this part, we consider two sightings. So one is the full data set, and the other is the few shot. So that means we use the full, first of all, we use the full data sets to train the traditional deep learning models, and we also use the few shot examples to few shot instance to train the traditional deep learning methods as well as the large language model-based methods. So from the results you can see, so this is the results achieved by our model. So even compared with the deep learning models trained with the full data sets, we can achieve a reasonable improvements, and compared with the models trained with the field data, we achieve significant improvements. And we also conduct application studies and case studies to verify the effectiveness of different components of our models. For example, the automated filtering strategy and the deep reinforcement learning methods to retrieve the hints, relevant hints, etc. And we do the hyperparameter analysis because there are two important hyperparameters in our model. So the first one is the training size. So from the results, you can see that too few training samples will result, in unsatisfactory performance, but with the training size increases, the performance increases gradually. But we can also notice that only marginal improvements when the size is larger than the threshold. Okay, and another important hyperparameter is the knowledge base size. So from the results, you can see that the accuracy increases when the size increases from 2 to 20, and because at this stage, because more and more hints included in the database, diversity will increase. So this will effectively help the large language models do more accurate inference. While when the size increases to 15, you can see there is a decrease in the performance. So this is because more hints may increase the complexity and difficulties to retrieve the most relevant hints. And also we compare the different designs of the rewards. We also try to use the absolute rewards achieved by the hint enhanced prompts. But the results show that the comparative reward is more effective. So then let me wrap up this work. Quickly wrap up this work. So in this work, we propose a reflective reinforcement learning LLMs, which aims to improve the performance by identifying and rectifying common errors in LLM's inference for recommendation. And we propose a novel learning paradigms that merge the capabilities of LLMs with efficient model training procedure. And we do extensive experiments to verify the efficacy of our proposed methods. And for the future works, we plan to extend the retrieval agent with more flexibility functionalities, such as we can integrate multiple hints selections and the multimodal contextual information. And the second type of works we have done is leveraging the reasoning capabilities of LLMs. So in this types of work, we are combining the LLMs with the traditional models. We aim to leverage the capabilities, the power of LLMs to enhance the traditional methods. So the first work was published in 2020, AAA 2025. So in this work, we aim to improve the robustness of the sequential recommendation. So as traditional sequential recommendation, robust sequential recommendation methods, they mainly rely on the data-driven methods. For example, they will leverage the co-occurrence of the items to have determined whether the training instance is reliable or not. But I think we believe this is not comprehensive as due to the data sparsity problems, etc. So that's why we use the LLMs to identify the semantic relationships between different items as complementary parts to enhance the data character for a more robust sequential recommendation. And the second work was also published in AAA 2025. So in this work, we're using the knowledge distillation methods to distill knowledge from the large language models and inject this knowledge into a small traditional recommendation methods. And to improve the efficiency, we design active learning strategies which will be utilized to extract a small set of the training instance with more, with high informative information. And we do have some archive works. So the first one is utilize the LLMs for multi-interest recommendation. So traditional, the traditional deep learning methods, they also do the multi-interest recommendations. Well, there is a major issue in these methods is that they assume the number of the interests in the sequence is fixed. They use a hyperparameter. And so in this work, we're leveraging the LLMs to infer, to reason, the interest behind each sequential behaviors. There is an issue that is, the granularity of the interest may be either very broad or very narrow when we are directly applying LLMs. So to address these issues, we do the alignment between the inference of LLMs and the traditional models. The last work is we're trying to integrate LLMs with GCN and to enhance the expressiveness of the embeddings learned by the GCN frameworks. Our work will, when conducting the convolutional with the convolutional layers, with each layers we integrate the semantic information obtained from the LLMs. So this model will consider both the topological structures of the graph as well as the semantic information of each nodes. Okay, so and the last tab is the several works we have done is the generative capabilities. So the first work is we're doing the social recommendation, the robust social recommendations. We leverage the generative nature and denoising capabilities of diffusion models to perform the network refinement, either remove the noisy connections or adding meaningful ones. So our presentation will be on tomorrow morning. Yeah, so you feel free to join the presentation if you are interested in this work. And the next work is we're also doing the user simulators, as Professor Flora. They also do the train the user simulators to simulate the user behaviors, right? So here we also leverage LLMs to play a role as the user simulator to simulate the user's interaction behaviors. So with this user simulator, we will be able to evaluate and optimize the recommendation algorithms. Okay, I think that's all from my talk. Thank you very much for your attention. So yeah.
Thank you for your insightful talk. As mentioned in the first work, when the size of large language models increase, I see that the performance of the models decrease. Do you have any solutions or advantages to solving this phenomenon?
You mean as the training size increases, the performance of the model decreases, or? Oh, sorry,
Yeah.
sorry, I can go back to the slides.
Yeah, here.
Here.
Yeah.
You mean the first figure, right?
The second figure.
The second
knowledge
figure.
base. Yeah,
Okay.
yeah.
Oh, this is the size for the knowledge base because we have a lot of hints generated by LLMs, right? And because we have a lot of training data, and then based on the training data, we will extract a lot of hints that the LLMs has made during their inference. And so the hints, the number of the hints will be very huge. Not very huge, but not very large. So with the number of the hints increases at the beginning, so there will be more diverse hints included in the knowledge base. So this will cover more mistakes made by LLMs. So this will increase the performance. But if you continue including more hints, so this will increase the complexity and the difficulties for our agent to retrieve the most relevant hints. Because we have the reflective utilization modules, which will utilize the deep reinforcement learning methods to select the most relevant hints given the session contextual information, right? So if the hints are too much, that means the action space is very large. So this will increase the difficulties and make the performance decrease. Yeah.
Okay, thank you very much.
Okay, if no further questions, let's thank the speaker again. And our next speaker is Dr. Qi Cao. She's a dedicated researcher and emerging leader in social media analysis on the web. She currently serves as an associate researcher at the Stakey Laboratory of AI Safety Institute of Computing Technology, Chinese Academy of Sciences. Her research focuses on popularity prediction of content, trustworthy recommender systems, and algorithm auditing. She has published more than 40 papers on top-tier conferences and journals, including WWW, KDD, NIPS, ICLEO, Wisdom, TKD, etc., with over 1,700 citations on Google Scholar, and winning the National Conference on Social Media Processing Best Reports Award in 2018 and the IEEE International Conference on Big Data and Smart Computing Best Paper Award in 2020. Welcome, Dr. Qi. Yeah. No, this window is not working. Can you open? It's already open. Oh, and then no, it's not working. Oh, okay.
Okay. Good morning, everyone. My name is Qi Cao. I'm coming from Institute of Computing Technology, Chinese Academy of Sciences. It's truly an honor to present our research work at Swarmer in the Web, and thank you for organizations and the recognitions. Before diving into details, I would like to introduce briefly about myself. As mentioned, I am currently an associate researcher at the Stakey Laboratory of AI Safety. My research interest mainly includes social media analysis and trustworthy AI on the web. Among my research fields, I have done some interesting work in the popularity prediction of online content, which also mainly utilize sequential and graph data to predict the future popularity of online content. And we have also conducted research about the robust recommender systems and algorithm auditing of AI systems. Due to time limit, today I would like to share you with our latest progress we have made in the robust recommender systems. And it mainly studies how adversarial attacks happens in a recommender systems and how to defend against such attacks to further enhance the robustness of recommender systems. I would like to start with the basic concepts, with basic introduction of recommender systems, followed with existing methods for adversarial attacks. Next, I would like to share our two research lines of defending against such adversarial attacks, and finally summarize. Let's start now. Recommender systems have been an important toy for information acquisitions and are widely deployed in various social platforms such as Twitter, YouTube, TikTok, RedNote, and so on. They may help users find interested content from a vast amount of informations. Depending on the scenario, recommender systems generally includes collaborative filterings and sequential recommendations. The former one taking the user item bipartite graph to modeling the user interest, while the later one based on the sequentials user has interacted to model user interest. Despite the success the recommender systems has achieved, however, the openness of these platforms also introduced vulnerabilities. Taking an example, in 2019, the New York Times reported that a certain great industry companies sold about 196 million YouTube views with more than $1.2 million, affecting video recommendations. In 2024, Guardian reported that Facebook employees found that more than 30 cases of political manipulations involving 25 countries on that platforms. We can take a more detailed understandings on how vulnerabilities of recommender systems happens. As shown in these pictures, in the left, normal users who have interacted with pizza and beer. When attackers in the right want to promote some target items, they generate fake users who interacted with pizza and beer, but also interacted with the target items. Then the recommender systems trained on these data may assume these two users are similar, and then recommend the target items to the normal users, affecting the normal users' experience and harm the recommender systems. To better and more thoroughly reveal these vulnerabilities, a growing body of research has explored the adversarial attacks in recommender systems. According to the goal of attackers, there can be two types of the attack goals: those aiming to degrade the overall recommendation performance or to promote target items. In terms of attack strategies, we can use user injection attacks or just modify the site informations. As for types of attacks, we can do poison attacks or evasion attacks. In recommender systems, the most practical and common setting is promoting target items by user injection strategies to poison the training model. Under these settings, as for attack methods, existing works. Oh, wait. Existing works generally includes the shilling attacks and the optimization-based attacks. As for the shilling attacks, they generally interacted. Oh, okay, thank you. They generally interacted with the target items and then interacted with some filler items according to different strategies, such as choosing some random items, popular items, or copy interactions of high impact users. For the optimization-based methods, they generally utilize gradient or inference functions as the signals to optimize the behaviors of injected users. To further adapt to the blackboard scenario and enhance the imperceptibility of injected users, reinforcement learning and generative adversarial networks are further explored. To defend against such attacks and improve the robustness of recommender systems, a lot of research efforts have also been made. As shown in the figure, you can see that there is a growing number of published papers on topics related to robustness in recommender systems, especially since 2019. Those existing works can generally fall into two types: fraud detections and adversarial training. The former one directly identify and remove potential fraudsters. However, the performance of these methods is limited by specific knowledge from heuristic priors or supervised fraudsters. For example, as shown in these figures, the detection-based methods trained on bad worker attack performs well when against the same type of attacks, but the performance drops a lot when they meet the new attacks as DP attacks. Then a natural question raised: can we improve the generalizabilities of these detection-based methods? Recently, as large language models show strong generalizabilities across a wide range of tasks, so can we utilize LLM's open world knowledge to further enhance the detection-based methods, learning from the specific patterns to a more general patterns of fraudsters? To explore these questions, we propose the low rank, which is accepted in the CCR 2024, which combines poisons with large language models for robust recommender systems. The most interesting part in LoRack is LLM-enhanced calibrators. This calibrator integrates both specific knowledge and open world knowledge modeling. As for the specific knowledge modeling, it highlights the differences between normal and the non-fraudsters within the current recommender systems. As for the open world knowledge modeling, we aim to extract the knowledge representations about the likelihood of a given user with interaction sequence of being a fraudster. So maximize agreement between the open world knowledge and the specific knowledges, we can better form the extract representations to consider the fraud's characteristic within the current systems. To train the calibrators, we design 3 training laws. The first one is the detection loss, which takes the non-fake users as positive samples and the normal users and potential fake users as negative samples. To prevent the calibrator from making overconfident predictions, we introduce a regularization loss that encourages the predicted values to be less extreme. Finally, we incorporate the mentioned agreement maximization loss into the training process. Okay, after we obtain the calibrators, the most simple way, we can just directly use the predicted value of the calibrators, which indicate the likelihood of a user being fake users, to adjust the weight of the corresponding users. However, as we mentioned in the training of calibrators, we actually do not know who are the actual potential fraudsters. So we take the normal users both normal users and the potential fake users as the negative samples. So it's actually challenging to guarantee a distinctive dependency between the PU of normal users and the potential fake users. As sure, we can see that the values of PU is always distinguishable between the normal user and the non-fake users. However, there may be some overlappings between the normal users and the potential fake users, as shown in the scenario 2. To solve these problems, we further propose the interactive weight compensation strategies by an adaptive threshold, which theoretically proved that to increase the weights of normal users and decrease the weight of potential fraudsters with increase of training epochs. Finally, we utilize the calibrated user weight to adjust the training of recommender systems to enhance the robustness against attacks. Experimental results show the effectiveness of both the proposed RARAG against point attacks while maintaining recommendation performance. Another line of works to defend against adversarial attacks is the adversarial training, which typically follows a min-max paradigm, assumes that the attacks severe impair the performance of all users, and applying the same perturbations of all users. However, we observe that in practice, only a small percentage of users are actually affected by attacks, as shown in this picture. We call this user as vulnerable users. Under such situations, applying the same small magnitude of perturbations may fail to protect the vulnerable users, while applying the same large magnitude perturbations may damage the performance of those users who are not vulnerable to attack, as shown in this figure. In other words, applying the same magnitudes of perturbations across all users may not be the most effective way, resulting in a trade-off between recommendation performance and protections against point attacks. This naturally then raises another questions. Can we identify the vulnerable users in recommender systems and applying user adaptive perturbations to both vulnerable users and invulnerable users? So in practical analysis, we found that a predominant portion of users has never been affected, and no user consistently demonstrate vulnerabilities. And for those users affected by the attack, they generally have varying frequencies. Further analysis based on the number of status changes can show that a majority of users who have been affected undergo several status changes, indicating that users' vulnerabilities dynamically evolve with the training of recommender systems. Based on this preliminary analysis, we first explore the relationship between users' vulnerabilities to attacks and the training process of recommender systems. Interesting, we find that vulnerable users are distributed at a smaller loss. In other words, it's indicating that the well-fitted users are more likely to be vulnerable. This may be due to that the point attack is actually exploit the system's fitting capabilities by creating deceptive correlations between user historical interactions and the attacker's choosing targets. As shown in these pictures, we found that the well-fitted users precisely model the third-order link, thereby showing high similarities with the target items. Conversely, the underfitted users failed to discern these patterns, remaining unaffected by the attack. In other words, users whose interactions are better fitted by the systems are more easily to be attacked by the attackers. Based on the above interesting findings, we propose vulnerable-aware adversarial training for robust recommender systems, which apply user-adaptive magnitudes or perturbations based on users' loss function, thereby providing an effective defense against poison attacks while maintaining the performance of the recommender systems. Experimental results show the effectiveness of the proposed measures against the attacks and even achieving the most impressive outcomes in enhancing recommendation performance. After this work, we further conduct some theoretical analysis of adversarial training by deriving the upbound and lower bounds of recommendation error. We find that adversarial training has a lower recommendation errors than the backbounds in both clean and point scenarios. In addition, applying the personalized magnitudes of perturbations based on users' embedding scalar can theoretically further enhance the robustness of recommender systems. That's all for my presentation today. To summarize, we explore the open knowledge embedded in large language models to enhance the generalizabilities of defense measures against the attacks. In addition, we explore the user vulnerabilities in defense, introducing a vulnerability-aware adversarial training framework, which applies user-adaptive magnitudes of perturbations, supported by both empirical understanding and theoretical analysis. Finally, I will also thank to all my collaborators for their contributions to this work. We have also write a survey about summarizing the current research on robust recommender systems. If you are interested, feel free to scan the code to explore more details in our survey. Thank you for your attention. Here are my contact information and personal homepage. Okay, thank you. Feel free to contact me if you are interested. Thank you again.
Professor Chisao for the wonderful presentation. Now we will open the floor for the questions. Does anyone have a question for her?
Okay.
Thank you very much for your sharing. I have a question. So for your first work, you mentioned the open source large language models.
For defense, so what the backbone large language models you are using, and how about the complexity? Yeah, thank you.
Okay, we use the Llama large language models in our experiments, and when I do not show the results, but when the size of the model increase, the large language model increase, the performance of our calibrators actually improve performance, because maybe the larger size the large language model is, the more open knowledge it can contain, and the more helpful for the detections of the fake users. Thank you. Okay, thank you very much.
Okay, let's move on to the next session. Dr. An Zhang received her PhD from the National University of Singapore. He is currently a professor of the University of Science and Technology of China. Her research focuses on the foundation models and AI agents. She has over 30 publications appear in the top-tier conference, including Europe's ICLR, WWW, KDD, ICML, SIGGRAPH, and Generals. Such as the TIPAMI and the TOIs, receiving over 2,000 citations on Google Scholar.
Hello, is it clear? Hello, could you hear me?
Yeah.
Okay, so hello everyone, I am An Zhang. It is a great honor today to have been selected as a runner-up for the Women in the Web, and to have the opportunity to give a presentation to showcase a series of my excited and interested recent works in the field of recommendation. So it is really a pity that due to some flight issues, I can't attend the conference in person and meet so many outstanding female researchers in this field. I hope I will have the chance to have a more in-depth conversation with you all face-to-face next time. So today my talk is about generative recommendations. First, I'd like to briefly introduce myself. I obtained my PhD degree from the National University of Singapore, and I'm fortunate enough to work as a postdoc fellow at the NEXT Research Center, and recently I joined the University of Science Technology of China as a professor. For my research interests, together with my colleagues, students, and collaborators, actually my research will focus on the development of foundation models and AI agents with a particular emphasis on large language model empowered agents, AI safety recommender systems. So first of all, I would like to thank you, Prof. Xun and Prof. Cao, for introducing a lot of background of recommendations. Basically, I'm doing something similar to what Prof. Xun is doing. So let's start with a sharp question. Why does recommender systems, or more broadly, user behavior modeling, now seem as prominent as computer vision or natural language processing? From my personal perspective, it should be just as important. So the data we generate in the real world present various reflections of the real world, right? Think about in this way. So in the perception world, we observe through vision. So leading to foundation models like diffusion models that performs incredibly well. In the cognitive world, we think through language, giving rise to large language models. But here's the thing. When we act and interact based on what we observe and think, we enter the behavior world, the domain of user behavior modeling, and yet we haven't seen a truly general foundation models. Why and how? Is it because of data? So basically my answer is, I don't know. But I believe a potential solution today lies in generative user modeling. As Feynman said, what I cannot create, I don't understand. So similarly, I would argue that what user behaviors large language models can now generate, large language model basically do not understand. So today I will focus on 3 core challenges. The first one is about user preference alignment. So to let language models to understand user preferences, let's take a step back and look at how large language models are trained. Typically, it starts with supervised fine-tuning and then reinforcement learning from human feedback. This second step is essentially about injecting human preferences into the model. And directly preference optimization is a more stable and simple way. So how about we could inject user preferences into large language model via direct preference optimization? So large language model-based recommenders basically lack explicit modeling of user preferences. For example, when user preference one movie over another, the large language model struggles to differentiate subtle ranking priorities. And more importantly, multiple negative items are ignored in today's large language model-based recommenders. Any possible solutions? Yes. We first use supervised fine-tuning to inject basic recommendation domain knowledge into the large language model. And next, we add an alignment stage where we explicitly model pairwise ranking preferences, and integrate multiple negative samples. And basically, we find out that, first of all, it is a SOTA performance as we expected, and it can generalize well across different large language model backbones. And more importantly, we find out that as the increase of the negative samplings, we can achieve a better performance, and it is quite computational efficient. So we find out that it is possible to inject user preference into large language model via DPO, where ranking information and multiple negatives matters. So basically, in our this paper, what we do is we propose a new loss function for recommendation. So let's move on to the second direction. The behavior-based alignment. One prevailing understanding holds that general large language models and traditional recommenders, such as collaborative filtering models, encode distinct representation spaces. Study of the relationship between these two, the language and behavior spaces, remain largely unexplored in the recommendation domain. However, as we find that, as a reflection of the real world, the cognitive world and behavior world, can we directly align the language space with a behavior space? The answer is yes. Basically, we can use linear mapping of the linearly map the item representation from leading language models can yield excellent performance. You can see that compared with some like new methods. And this means that user item semantic embedding as ID embedding is a possible solution for futures recommendations. And we found out that this is TSNE figures. Movies about like superheroes and monsters clustered together in both language and behavior spaces. And also you can find that the user intention here are also clustered. So based on this, we find out that, well, the collaborative signals encoded in the language space scale with model size. And more importantly, it seems like language model may implicitly encode collaborative signals in recommendation. The language model, no recommendation, all right? So can we reshape the recommendation paradigm with language representations? So we propose our model AlphaRec, and this does exactly do to transfer the recommendation paradigm. It is a simple, cost-effective, and supports zero-shot and intention-aware recommendations. Basically, it is very, very simple. It uses a language representation of item titles as input features, and it only contains 3 basic components. First, nonlinear projection. Second, graph convolution. And third one, contrastive learning objectives. And we find out that, first of all, it is quite simplicity. It can converge very, very quick, even compared with LightJSON. And it is superior recommendation performance. The second one is, of course, AlphaRec can achieve excellent zero-shot performance on entirely new data set, which means when we compare, like, you can find out that when we compare with even fine-tuned LightJSON, and AlphaRec can achieve even better performance. And it is on entirely new data set, which means AlphaRec never see this kind of like data set before. And more excited about that, AlphaRec can perceive language-based user intention and refine recommendations. You can see these examples like when we just add this user intention, this text into our model recommender, we can refine the recommendation without fine-tuning the recommenders itself. So basically, we find out that language representation may reshape the recommendation paradigm in the future. So for the third part, user intention understanding. Basically, we found out that large language model is powerful, all right? So how about agent, large language model-based agent? So we try to use agent to simulate users. So the first question is, can large language model-based agent generate faithful user behaviors? What we do is we build 1,000 large language model-based generative agents, which are initialized with real data and augmented by GPT. And we also have item profiles. Based on this tool, we have memory and action modules enable agent to recall past interests and apply future actions like watch, rate, evaluate, and interview. And based on this, we have a recommendation environment agent for rank. This can conduct like page-by-page manners recommendation, and it has pre-implements various recommendation algorithms like MF, LightJSON, VAE. And based on all of this, we find out that this kind of agents are capable of preserving the user's social attributes and preference like this. Second, more importantly, we find out that incorporating agents' ratings as augmented data, we can basically enhance the recommender's performance. And then we do interesting tasks, like we try to discover the causal relationship among all the features. And we can basically find a reasonable causal graph. And third one, we can actually offer a simulation platform to test and fine-tune recommender models by using Agent for Rec. So this paper tells us like large language model-based AI agents are capable of generating feasible behaviors. And we find out that actually accurate interactive recommendation is a complex task, and it may require various capabilities, like we need long-term user preference understanding, short-term user intent analysis, and large-scale item modelings. So we feel like we can change single expert into a network of specialized experts. So basically what we do is we try to decompose the recommendation into fine-grained subtasks. Like we will decompose this recommendation as like one of retriever, one of rewriter, and criticizer, recommender, re-ranker, responser, lots of expertise. And then we do a collaborative environment where multiple experts, each with distinct roles and specialized attributes, work together to handle this complex recommendation tasks. And this is an example, like the users want some movies about strong female movies. So the recommender first retrieve to explore historical interactions to get relevant data, and then the rewriter expert refine the user's intention, focus on a strong female lead. They change the intention. And then the re-ranker expert and recommenders evaluate the candidates and identify the Mulan as a best match. Finally, the responders expert explains the recommendation to the users. Basically, in this way, this is what we do using networks of experts to do the recommendation. And we find out that very interesting, like collaborative intelligence between experts can lead better performance compared with a single model or agent. And we find out that collaborative intelligence can potentially be achieved by a network of experts in recommendation. So basically what I introduced before is about large language model. But for generative recommendation, we can also consider like diffusion models. So we also explore the diffusion-based recommenders. Also, we try to adapt personalized rankings to diffusion-based recommenders. And we find out that, yes, it achieves ZOTA performance as expected, and it can have better zero-shot performance in general sequential recommendations. And more importantly, we find out that when we increase the embedding size about the recommendation, diffusion-based recommendations, it can actually achieve comparative performance compared with traditional recommenders. We feel like, well, diffusion-based models, like diffusion-based recommenders, is a potential solution for generative recommendations. And also it is possible to inject user preference into diffusion models where embedding size matters. And also, we try language representations in diffusion models. We find out that language representation can assist diffusion models in better understanding user behaviors. We can find out that by using historical interactions and intentions, we can finally find a better distribution about the target items. And language representations can basically provide more controllable guidance for diffusion-based recommenders. After that, we also try to find out a way to bridge the gap between the semantic and the behavior spaces by learning ID embeddings within the non-space of language embeddings. We find out that by fusing the semantic ID embeddings in recommendation, we can find potential powerful solutions in recommendation selections, in recommendation system, sorry. So basically, what we have is we have several language model based recommendation. First is about we're using like DPO, softmax DPO loss to achieve better large language model based recommenders. And the second paper is we try to leverage the language representations to help recommendations. And this paper is very interesting, and I think it has some insight. And the third one is about agent for rank. We try to build large language model agent to simulate recommendations. And the fourth one, we use network of agents to solve a more complex recommendations problems. And the last three papers is about diffusion-based recommendation. So the first one is we're trying to use diffusion models by injecting recommendation signals and also multi-negatives to boost the performance, recommendation performance. And iDreamRec, we're trying to have text-guided diffusion models. For the last one, AlphaFuse, we're trying to, both in diffusion-based and large language model-based, we're trying to fuse the ID embedding with semantic embeddings to achieve a better performance. So basically, this is what we do recently in recommendations. Thank you.
Okay, thanks for the Professor Anzhang for the wonderful presentation. Also, today we are dedicated to recognize the Professor Anzhang as the runner-up of the year's Women in the Web program, a recognition for her strong research capability, clear vision, and impact work. Okay, congratulations, Professor Anzhang.
Thank you. So any question?
Okay, does anyone have some question for the presentation?
Representation, this one, right?
Yeah.
Okay, I go back.
Hi, Professor. I just have a question, because my research focus on the scientific community. So we're working on the scientific papers and also the authors. And actually, I'm doing the same work, we're trying to create embeddings for those papers and also embeddings for those authors. And when we pull them into 2D map, they look like exactly the slides you show, they separate into different groups, just this one, the language space and the behavior space. So because those publications, they group together and author group together, and in your case use linear mapping to connect them, right? So I just want probably we could applying this your structure into the scientific community, that we could get a recommendation for those authors based on their publications. So how do you think about that idea, or do you think it's doable?
Yes, of course. I feel like it is an excellent idea because basically, this work trying to say that, well, large language model learns a lot, right? So
Yeah.
I feel like your idea is actually quite work, I think. And if possible or you are willing, you can ask me to join together to do that.
Yeah, I think definitely because we're trying to use, some language model like to create the embedding, based on their title and the abstract of those publications. And we also we just in the stage like how could we get a good representation for authors as well. Like we're trying to
Sure.
use the average, of their
Yeah, average.
publications. Yeah, but I think yeah, I will send you an email. Yeah, definitely we will collaborate
Yeah,
in
sure,
the
sure,
future.
sure. Because yeah, sure. Like you mentioned a very important problem, like how to represent user here. Basically, what we do is we use average. We feel like
Yeah.
average is an excellent like function to represent user because we go back to recommendation itself, like traditional recommenders. Basically, what they do is they're trying to use the average of the item the user interacted as a representation of the users itself.
Yes, actually, I did that, and also I plot the authors only in the 2D map, and I think yes, they group together in somehow like if they they work.
Collaborated.
Yeah,
Yeah,
they collaborate
yeah.
or probably they work on the same research topic. Yeah,
Yes.
so I think definitely it's quite close, and your presentation is wonderful. Yeah, thank you.
Thank you so much.
Okay, so now I think our session is done. Have a great day.
Bye.
Bye.